Welcome to homework.
This is the answer to Chapter 15, problem number 15 from the Smith Organic Chemistry textbook. And this problem asks us to draw the monochlorination products formed when each compound is heated with chlorine gas. And we're asked to include the stereochemistry at any stereogenic center. Okay, and so looking at A, there are 4 products that we can get here for A. So if monochlorination occurs at a terminal carbon, we're going to get this product. And there's no induced stereochemistry here because the carbon that this reaction is occurring at still has 2 hydrogens. And so it doesn't have 4 unique bonds, and so it's not a chiral carbon. Okay, the second potential product that we could get would be chlorination at the center carbon. So this product, carbon number 3, gets chlorinated. And here again, there are technically 2 ethyl substituents on that carbon. And so it doesn't have 4 unique bonds. And so it's not a chiral center. Okay, so the other 2 possibilities both involve chlorinating what would be carbon number 2. And if we chlorinate carbon number 2, we are going to get some stereochemistry. So we can have the chlorine add from the front, and we'll get this product. Or we can have the enantiomer of that product. Okay, so there we go. There's our two enantiomers there. All right. And so for B, we're going to have a mixture of 6 products for B. And so the first product is going to be a result of the chlorine adding to the methyl group here. And if that's the case, again, there's no stereochemistry because that carbon is still going to have 2 hydrogens on it, so it's not going to be a chiral center. And the other non-chiral addition product would be chlorination there at that tertiary carbon. So there's not going to be stereochemistry induced by that reaction. And now the other 4 products are going to look like this. So we can have the chlorine add here. And so now we're going to have stereochemistry at this methyl group. So it can be cis or trans to this methyl group. So in this first example, we'll make it trans. It can add so that it is cis to the methyl group like that. Oops, that should not be a chlorine. Right, so that's just the methyl group. And then the other 2 enantiomers that we can get are going to be the others. So if the chlorine is on a wedge, then again, it can be trans to the methyl group or cis to the methyl group. So just like that. And those are our 6 potential products for B. So then looking at C, for C, we're going to have 4 potential products. So if we get chlorination at the central carbon, there's not going to be any stereochemistry involved there. Okay. If we get chlorination at a terminal carbon, there won't be any stereochemistry involved there. Okay, and now we could also get chlorination at one of the secondary carbons in the chain. So if we get chlorination here, we are going to get some stereochemistry. Okay, and then we'll have the other enantiomer of this as well. Okay, and then so looking at D, for D, we are specifically told to consider attack only at C2 and C3. And so if we get attack at C2, that's pretty simple. That's going to make that carbon no longer a chiral carbon. And so we'll get this product. And so we've actually gotten rid of stereochemistry there. And then if we consider attack at carbon 3, we're going to get two potential molecules based on whether the carbon or the chlorine adds cis or trans to the chlorine that's already on this molecule. So the cis version would look like this. And we can also have a trans addition. So like that. Okay, and so those are the three possible products for D. When we only consider carbons 2 and 3, as the problem told us to do. And this is the answer to chapter 15, problem number 15.